Alrighty, today we're going to talk about chemical bonding. We're going to start with some little introduction notes on things about bonds, what a bond is, and then go into specific types of bonds and then how those look in real life. So, to get started, a chemical bond. What is a chemical bond? We've talked about chemical bonds before. You know that a chemical bond holds atoms together to form molecules and compounds. We talked about that in our previous unit. We know a compound is two different elements that are chemically bonded together. So the chemical bond is just what holds elements together to make compounds like NaCl or salt or H2O like water. Okay, so any compound is held together with chemical bonds. So we're going to talk about how those bonds form. One super important thing you need to know about that chemical bond is that a chemical bond is formed with the addition of valence electrons. And we know that a valence electron is on the outermost shell of an electron, or of an element, sorry. So if we go over to our little whiteboard here, I'll type in here. So again, just to reiterate, a chemical bond, we know it holds two things together to make a compound or a molecule, and this is caused by the electrical attraction between the valence electrons of atoms. Okay, so the electrical attraction between the valence electrons of atoms. So the valence electrons interact to form these bonds. And there's two different types of bonds. We have an ionic bond, which we've talked about in our previous assignment on the bonding inquiry activity. So an ionic bond. The definition of ionic bond is it is a complete transfer of electrons. The complete transfer of electrons. In addition to this, it's between a positive and negative element. And we haven't talked about what I mean by the positive and negative element yet, so we're going to talk about that. How about now? So let me go ahead and pull up a picture of a periodic table. So here's our periodic table. You know what this periodic table looks like. I've seen this before. We've already talked about the valence electrons on the periodic table. We know that as we move to the right, the number of valence electrons increases. So all of these elements in this column have one valence electron, whereas all of these have two. All of these have three. All of these have 4, and 5, and 6, and 7, and so on. There's also associated charges with these things. We know that we have our staircase located here. And we know that to the left of our staircase is all our metals, and to the right is our nonmetals. Generally, what's going to happen is everything to the left of our staircase is going to give away its electrons and thus have a positive charge, whereas everything to the right of our staircase is going to gain a negative charge in bonding. Okay, so just remember that moving forward, that everything to the left will have a positive charge and everything to the right is going to gain a negative charge. So, an ionic bond then is between a positive and a negative element, meaning there's something from the left side of the periodic table and something from the right side of the periodic table. So we know that an ionic bond is between a nonmetal and a metal, generally. Okay? Our other type of bond then, as we know as well, is a covalent bond. I don't know why it won't let me move anything. There we go. It'll just be way over here. Is a covalent bond. Okay? And the covalent bond then is the sharing of electrons. And it's just between two atoms, and generally it's between two nonmetals. It doesn't always have to be like that, but generally it's between two nonmetals. So on your test, when I ask you to identify if something is an ionic or covalent bond, you need to recognize is it a metal and a metal, or a metal and a nonmetal, or two nonmetals to decipher whether if it's an ionic or covalent bond. Okay, just some other general notes that'll be helpful for you to have is that atoms have a neutral charge when there is an equal amount of protons and electrons. That should not be new to you. We learned that last unit. So there's always going to be a neutral charge between our atom when there's an equal amount of protons and electrons. However, we have these things called ions, and we've again already learned about ions. We know that ions is a charged particle. Okay, a charged particle. And these ions are caused when there is an unequal amount, oops, I spelled that one, an unequal amount of electrons. So it happens when you add or subtract electrons. Okay, so ions are what form when we add electrons or subtract electrons. And when we have that positive charge that results, we get a cation, which again we've talked about, or we get a negative charge that results in what's called an anion. Okay. So let's go back to our PowerPoint. We now know what an ionic bond is, what a covalent bond is, we know what an ion is, so we're going to be seeing this in how things bond. So again, valence electrons are how things interact to make bonds. I do have a little video for you to watch here in a moment too. So ionic compounds are really strong bonds, adding to your notes. Okay, they have a really high polarity difference. So one of them is really electronegative while the other one is not very electronegative. While covalent compounds, we know they share and they're generally a weaker bond. One big thing to notice is that H is included in covalent compounds, okay, because H, hydrogen, is not a metal, it is a non-metal. We'll skip this video for now.
Ionic bonding.
And then we'll look at the creation of ions. This is going to be covered in a separate video, so make sure you watch that supplemental video and let me know if you have any questions. Thank you.